Evan wasn't energetic yesterday.
He was being annoying yesterday.
Never. None of you are ever annoying.
Jamerson.
He came home and started yelling at him.
Except for Cooper.
Never. You guys are never.
Henry, you almost got him on time.
167 questions. Problems you want to see worked off 167. My last class. I wasn't going very fast. Wasn't doing a whole lot. We got Dylan. Did you ever find it?
No, I did not.
Flipping on me. Pretty sure you did it.
I know I did at least half of it, so we did it all together. We went to 13. Well, same difference.
On 167. Questions. What I started to say on my last class, we probably got like 10 of the homework problems done together. I think we could probably get just about all of them done together if I would have been hurrying instead of I was just sort of being lazy and slacking a little bit. That would help some of you, especially those who've been out and got stuff to make up, get into me. Questions on 167, problems you want to see worked? Don't be afraid to ask.
Let's get our notes done.
Get your book open, Dylan, before you open up your mouth.
22.
22. 22. Stuff we do today is not hard, but it's a little confusing. And I'm sure several of you will go, "This isn't math. Why are we doing this? Why is there sentences in math?"
There's not.
Problem 22. They want you to write the conditional statement, so write it in if and then form, and the converse. Determine the truth values of the conditional statement and the converse. If it's false, find the counterexample. If it's true, write a biconditional statement if possible. So if it's true. It says 89 is an even number if it is divisible by 2. Let's write it as an if and then statement. And we were talking about this in my first class. English, probably the dumbest language in the world.
It's not
No,
probably,
actually
it's
Spanish
most
is.
definitely.
It's most definitely, all right?
That's good, James.
And that's why if you see other people come from other countries over here, and then people laugh at them because they talk, and they sort of talk backwards like, they say, I can't even think of something, but they'll say like, I don't know, but their sentences seem backwards compared to ours.
Like name your instead of yours.
Right. So everything seems backwards compared to what we do. It's not their fault. It's us. Our sentences are stupid. Our sentences are set up stupid. All right? And I never really realized this, but my wife went to college for sign language. And in sign language, everything's straightforward. When you're going to say something, you say it in that order. Well, in the English language, we mess things up and move the words all around. Okay? The easiest thing I can show you of that is, what's today's date?
27.
October 27, 2021. If you're in the United States, that's the way we write it. Nowhere else in the world do they write it that way.
27 October.
They write 27 October 2021. Which one makes more sense?
27th of October.
The top? October 27th.
Why does this one make more sense?
27
Because it
October.
tells you what 27 is.
October
The other one
27th,
is just October.
It goes in some kind of order, doesn't it? Smallest, middle, large. Day, month, year. For some reason in the English language, we do month, day, year.
But when we got to be more serious.
Because we're idiots.
Especially.
Yep, I did ours.
Doesn't make sense.
Yes,
Right?
All right? And that's the same way with our,
So it makes all of us.
that's the same way with our English language. A lot of things in another language, like if you're taking Spanish, in Spanish it goes, the sentence goes subject, verb, so on, so on, in some kind of order every single time. Not some of the times, not part of the times, like it does in English language, all the time. So in this one, if we want to write an if and then statement for 22, back, I'll get off my soapbox now about how dumb we are in America, or in the United States, I should say. It says if, we got to turn it around. If it is divisible by 2, then 89 is an even number. This part's called the what again?
Hypothesis.
Hypothesis. This part's called the. This is going to be very important for what we do today, so you got to know those two things. Says write the conditional statement. We did that. Is this conditional statement true or false?
True. That's like, wait, because like it says if. That's where I was confused.
It's false, isn't it? Because 89 is not an even number. It's not divisible by 2, so it's false. What would the converse, what's the converse do to the statement?
What?
Switches the hypothesis and the conclusion. So it's going to say what?
If 89 is an even number,
If 89 is even number,
then it's divisible by 2.
then divisible by 2. Sorry, I'm starting to abbreviate because I'm tired of writing already. Is that true or false?
Yeah, true. True.
If 89 was even, it would be.
Yeah, that's true. I don't know that we want to really go that far. Is 89 an even number? So what's that make the whole statement? False.
But it's an if.
Right, if it was an even number. But since they stuck the 80, if they just said if a number is an even number, then maybe. But with this, we'll try one to say false. To be biconditional, and this won't work, but I'm going to show you how to write a biconditional. To be biconditional, this has to be true and this has to be true. So if they're both true, then we can write it as one statement and say that the whole thing is true. If we got rid of the 89, then we could make it a biconditional statement and we could say a number is divisible by 2 if and only if it is what? If it's an even number. That would be a biconditional statement. This one we can't, you shouldn't have to write the biconditional statement for this because they were both false. If they were both true, then we could say that, but this one we can't say it. Next question.
29.
29. Directions on 29. Write each biconditional. No, that's the wrong thing. Doesn't have any directions.
What is the true value of?
What is the truth value of, and they give us this big long thing, let's see, parentheses, not P, Q, close parentheses, that symbol, R, and they tell us P is true. Some of you could be helping me out here. I still need to get my glasses. Q is false. R is true. Thank you. Just like in algebra, what's the first thing we have to do if we do what's inside the parentheses? So this says, what's this little tilde mean?
Not.
Not. So not P. Was P true or false?
True.
True. So not P has to be what? So let's just say that. So we know that that part's false. What's this symbol again?
Or.
What do we know about Q? Now, for the parentheses in, this part's false. We're using the word or, and this part's false. What's that tell us about the whole thing?
False.
The whole thing is false. What's this symbol mean? And. What did it tell us about R?
True.
So we got, this is false. The word and, this is true. If it's and, what has to be true for the whole statement to be true?
Both.
Both parts. So what's that tell us about this entire thing?
False.
All false. Somebody tell me what's P stand for? Good answer. Do we have any idea what P stands for?
No.
Do we know what Q stands for?
No.
Do we know what R stands for?
Nope.
Do we really care?
Nope.
No. All we care about is the fact that this whole thing is false. Next question. Which one?
Huh?
Thought somebody said one.
60.
Next question. 31.
The law of
31. Luca has a bag of miniature chocolate bars that come in two distinct types, dark and milk. Luca picks a chocolate out of the bag. Use the following statements to determine whether the statement, and they give us that statement again, I'll write it up right here in a second, is true. Oh, no, that's not what I meant to do. This is 31, right? Somebody read me that, what it says. Just the little parentheses and
So
not,
parentheses, not P, V.
V,
Yeah. They're not Q.
not Q.
Yeah.
And we're trying to decide whether that's a true statement or not. Whether that's true or not. Down at the bottom, they tell us P, the chocolate bar is dark chocolate. And Q, the chocolate bar is milk chocolate. Are both those true statements? Could be, right? Because we don't know what they picked, what Luca picked out of there. So we know P is a true statement, Q is a true statement. If P is a true statement, then what's that tell us about not P? It's got to be false. What's this symbol again? Or. What's this symbol? Not Q. So is that true or false? That's false because we know Q was true, right? So now we have that. We want this. False or false. What's that tell us about the whole statement here? It's false. So if we have a false statement and we're saying the opposite of that, then what do we know about the entire thing? So this entire thing is true. What did Luca pick, a dark or a milk chocolate?
True.
Yeah, that's right. One of the two. We don't know which one, but we know that Luca picked one of them. Next question. No others, we're ready? Cooper, don't make me throw something at you.
Do it.
Because I'm going to need everything I need to throw today for Ethan K back here, talking a bunch.
Well, just take his bow and arrow and just shoot stuff at him.
There's no arrow.
I know, but if I got to waste them on you, then I won't have them for him to throw at you.
Well, you can just have enough to throw at both of us.
If you haven't already, grab the notes from up here if you haven't already.
You have it on.
Fill in what you need to fill in on this
A
part.
lot of writing.
Also know we will have a new seating chart, usually every 9 weeks. I've been out a couple of days, so I haven't made them yet, but we will have a new one coming up here real soon. You do me a favor, turn that on. Push the timer button. Take it up to 8 hours, so because I always forget to turn it off. And then push the ionizer button. That's supposed to be what kills all the germs and everything, or whatever. It is. Yeah, it's an ionizer. It like conditions the air, takes out.
How do you condition air?
It's like
What do you think of air conditioning is? It conditions the air. Now the bad thing is, air conditioning and a furnace, they both condition the air. Kellen, you don't want to lose that, do you? Better get it out of your ear.
Maybe just what cars completely.
He did. You condition the air by making it cooler or hotter or whatever. Sorry.
I got COVID and I have too. Don't
Doing all
worry.
that. I was fine yesterday.
I got COVID too. Don't worry.
No,
You can hear me.
I can hear every.
I died.
Huh? That might be.
It's worse than that. That lasts for hours. That looks
Dogs live there and doesn't matter.
On this, deductive reasoning. We talked about inductive reasoning the other day. Inductive reasoning deals with what?
We did.
Patterns.
Patterns. All right? Deductive reasoning. Deductive reasoning deals with using rules, laws, theorems, and here it's going to be like theorems, postulates, axioms, so on, so on. So, as we go into this a little farther, today's not too difficult, but after this, it's going to start to get to be stuff that you probably will not like a whole lot because you will do a lot of writing. So you've got to know the difference between deductive and inductive reasoning. Deductive uses rules of facts, something, anything along those lines. Inductive uses patterns. A valid argument. A valid argument is an argument is valid if it is impossible for all of the premises or supporting statements of the argument to be true and its conclusion to be false. In other words, and I think the next slide, then the next slide's a Venn diagram in it. Let's hold off on my explanation of that for a second. We'll talk about valid argument here in a minute. On the Venn diagram, draw in what you need to draw in there. Hopefully you've seen a Venn diagram before and sort of know what it is.
It's circles.
It's usually circles. It doesn't have to be circles, but normally it is. I'm going to draw another Venn diagram up here in a second to show you a little bit. A Venn diagram is just like a tool that you can use to help with deductive reasoning. If I put a shape and that shape falls right there, what can you tell me about that shape? It's a polygon. Cooper. Last one today, all right? No more. If I put a shape right here, we know it's a rectangle and it's a
A square.
polygon, but it's not a square and it's not a pentagon, right? What if I put a shape there?
Square, rectangle.
Could be called a square, could be called a rectangle, could be called a polygon, so on, so on, so on. That's what Venn diagrams do. If I have this is all our students here in the high school. and we take another circle and we put it in there, and we say the geometry classes.
That's a lot of kids.
So if I put a student in there, we know that that student takes what? Geometry.
In high school.
Now, and they're also in the high school. What if I wanted to put the Spanish classes in my Venn diagram?
They could overlap.
They're gonna maybe overlap, and then when we put a student in here, what do we know about that student? They're in geometry and Spanish. So that's all a Venn diagram does. Alright, Venn diagram sort of tells you stuff, and you gotta be able to look at the Venn diagrams and pull things from it. Fill in what you need to fill in here. This is where I wanted to talk about a valid argument. With a valid argument, if you're a lawyer or a judge or somebody sitting on a jury, an argument is valid if, so this lawyer's making some argument, you're going to consider that a valid argument if it makes more sense for that argument to be true than the opposite of that to be true. All right? What do they say when you're in court?
I don't
What
know.
do you have when they're trying to prove if somebody's innocent or guilty? You have to be proven guilty. Close. That's true, but you're proven guilty beyond a reasonable doubt. Right? Beyond a reasonable doubt. Does that mean you're for sure that that person is guilty?
Nope,
No,
allegedly.
but it's more likely that that person is guilty than it is the opposite, than it is that they're not guilty. All right, so beyond a reasonable doubt, and all that means is if Zach has doubt that the argument that this lawyer made, trying to prove that this person is guilty, if he has doubt, and it's reasonable doubt, it's not just something ignorant like goes on in our country a lot of the times with our presidents and our politicians and stuff, and we just say, oh, this guy's an idiot and this guy's intelligent. And again, I don't want to go into politics because in my book, all of them are what? Stupid. Thank you. I don't care who it is. They all got their bad points, they all got their good points, and the one thing I know is they're all making more money than I make. And who pays for them to make that money? Me. And that makes a whole lot of sense to me that I'm paying somebody to be an idiot.
When you could just pay an idiot to be an idiot.
Right. And it probably costs me
pay
less.
Jameson to be himself.
I know.
So, if Zach thinks that this person didn't, beyond a reasonable doubt, and what they mean by, again, by reasonable, is it can't just be something off the wall where you're saying, I just don't believe them because she's wearing a gray suit. That's not reasonable, all right? That's a valid argument. A lot of times, if you're with your parents, Silas might make a valid argument with his parents. And you probably know when you have a valid argument, because what do your parents do?
Don't say it to me, I'm your parent.
Exactly. They walk away from you, they say, I'm done with you, something like that, and because now they can't argue the opposite. They can't argue against what you're saying. You make some valid argument to your parent, and a lot of times they end up just saying, all right, I'm done talking with you. Go away. All right? And they walk away from you. Because you've made a valid argument, and they can't invalidate what you're saying.
They feel stupid.
I don't know if they feel stupid or not, but they just don't.
That I'm
They don't want to admit that
That might be.
Can't accept it.
they walk away.
Find this on your paper there. We're going to decide inductive or deductive reasoning. If a student is late returning a library book, then he or she will be charged a $2 late fee. Chang returned a library book late, so he concludes that he will be charged a $2 late fee. Inductive or deductive? Cooper says inductive.
That's deductive.
It's deductive?
That's like a rule.
Is this a rule?
Yeah.
So which one is it?
Deductive.
Deductive. Now, could Cooper have maybe have been right if they changed the sentence around a little bit? It might have said, Chang got charged $2 last week when he returned a late book. He got charged $2 the week before when he returned a late book. Week before that, he returned a late book and got charged $2.
Dude, you be broke.
Now today, he's going to return this book and he knows it's going to be late. He probably wants to make sure he has how much money in his pocket? $2. Next one. Every time Tamika has worn her favorite jersey to a football game, her school's team has won the game. Tamika is wearing her favorite jersey to the football game tonight, so she concludes that her team will win the game. What's she using? Inductive. Inductive. She's using pattern. Is there a rule that when she wears that jersey, that her team's going to win for sure? No. If that was the rule, then Tamika would sort of be an idiot if she didn't
Well,
wear
the
the
national
jersey.
trail would actually be good.
The team must be. Well, not if the team we played had people like that.
Next. Law of detachment. It means it flies. Sort of. Up the other time. It's that, except it's the second time we saw it. Law of detachment. Remember, this says if P implies Q, if that is true, and the statement P, what's P in this case? P is the what in this statement? If it's at the beginning. It's the hypothesis. Q is the, make sure you're watching closely. P is the hypothesis, Q is the conclusion. If you know P implies Q, if that statement is true, and P all by itself is true, the hypothesis all by itself is true, then we can make the conclusion that Q all by itself must be true. And I usually make up just dumb things like this, just watch. Don't make this harder than it is. When you're doing the law of detachment, it's like you're given 1.5 statements. So you're given a whole statement, that's this, then you're given a half statement, then we can make some conclusion from that. If I make up something silly like, if $, then smiley face. This doesn't mean anything. I'm telling you it's true. All right? And then I say this. $, all by itself is true. So I'm telling you this is true, and I'm telling you this part's true. The conclusion that you can draw from that is that we can detach this conclusion here and put it all by itself, and it has to be true. That's all law of detachment is. Law of detachment says if we take the hypothesis and the conclusion of a statement, separate them. If the hypothesis is true all by itself, then the conclusion all by itself has to be true. So looking at this example, what's the hypothesis in this statement? Car's out of gas. That's your hypothesis. What's the conclusion? It will not start. That's your conclusion. Then it says Sarah's car is out of gas. Notice, that's the hypothesis. And we're saying Sarah's car is out of gas. What conclusion can we draw from that? Sarah's car won't what? Sarah's car will not start. Notice that was the conclusion. So we're putting the conclusion all by itself there. It does not work backwards. This is what you got to be careful of when you're using the law of detachment. So if I do this, if I had this statement, if, and I'm going to write this, I know it's not proper grammar, but if car is out of gas, then won't start. Then I write this. So I know I'm telling you that that's true. Then I'm telling you that this part's true. Car, let's make it Sarah's. Sarah's car won't start. What's the hypothesis in this original statement again? What's the conclusion? Where did this come from? That came from the conclusion. When we go to draw our valid conclusion, when we go to try to come up with our own statement that we know is true, can we now say Sarah's car is out of gas? Is that going to work?
But it could be other things.
Exactly. So is that going to work?
No.
So notice here, it's when you're using the law of detachment, it's got to be the hypothesis, the conclusion, then the hypothesis all by itself. Then we can say the conclusion is true all by itself. Here, we use the what? The conclusion. So this will not work. And what we write, if it's that way, no valid
Answer.
conclusion.
Could you just put in it?
No. No valid conclusion can be drawn. Doesn't work if it's backwards. All right? Let's do this one. Hopefully this will help. Use a little algebra to try to, those of you who maybe think a little more mathematically. If x plus 1 equals 3, then x equals 2. We know that that's true, correct? So if I separate this and I put x plus 1 equals 3, and I'm telling you that that's a true statement, what's our conclusion that we can draw? X equals 2. Now watch what happens if we turn it around. If x plus 1 equals 3, then x equals 2. If I start off and I say this, x equals 2, so we know x equals 2. Does that automatically mean that our equation that we had to have was x plus 1 equals 3? No. Is there many, many other equations where x equals 2? Yeah, so this one doesn't work. We can't draw that conclusion. Law of detachment. Circle detachment. What's detachment mean again?
Talking apart.
Take apart. Take apart. Too much chatter. Take apart. Just another example here. Determine whether each conclusion is valid based on the given information. Write valid or invalid. Explain your reasoning. To go on the field trip, a student must turn in a permission slip. First thing we should do is we should write this as an if and then statement. If what's true. Here's where you got to be careful with our dumb English language again. What's the first thing you got to do? Turn in the permission slip, and then you're allowed to do what? Go on the field trip. So if permission slip, and I'm just writing this real quick, then field trip, right? What's the hypothesis there?
If you turn in the permission slip,
Then
you can go.
that's the conclusion, right? Mariana turned in her permission slip. Can we draw this conclusion? That she can go on the field trip then?
Yes.
So that means that is a valid conclusion. That is a valid conclusion. Notice, all it did, hypothesis, that's not the hypothesis. Hypothesis, conclusion, we separated it and we put the hypothesis down here all by itself and said it was true, then that means the conclusion all by itself has to be true. And that's the conclusion we can draw. Next one. If a figure is a square, then it is a polygon. What's the hypothesis here? What's the conclusion? Next, figure A is a polygon. Where did that come from? That came from the conclusion, didn't it? Is that going to work for the law of detachment? So can we say figure A has to be a square? So this one's going to be invalid. Got an invalid conclusion. We cannot draw that conclusion from what we are given there. And think about it. If I look at this first statement, if I go back to my Venn diagram, these are polygons. And we had rectangles and squares inside there, right? Squares, rectangles, and I had another circle out here that was like pentagons or something, it doesn't matter. So if a figure is a square, then it is a polygon. So we're starting off and we're saying, all right, if a figure's in here, is it a polygon? Yeah. We know figure A, we know figure A is a polygon. So we know that figure A falls in here somewhere. Does that mean it has to be a square? No, it could be like here, couldn't it? And then it's just some polygon. So that's why that one is invalid. We can't say that. Law of syllogism. Law of syllogism. Cooper, you never found it? Huh? Here. I know you haven't used it yet, so make sure you don't lose this. Here. Go. Because you're not going to be one that's going to be.
Stop it. No, it's not.
Then you can keep it here.
No.
Don't worry, Miranda, they'll be sitting up front. Jameson's enjoying it because he knows he's being good and he's saying, hey, Ebersole's gonna move me to the back next time. Law of syllogism. For law of syllogism, you've got to be given 2 complete statements. And I'm just giving you something to, hopefully you can tell right off the bat, hey, which law am I using? For law of detachment, it's like a whole statement, then a half, and you can draw a conclusion from it. Law of syllogism, you got to be given 2 whole statements. So it's going to say something like, P implies Q, and Q implies R. So 2 whole statements. When you're given these 2 whole statements, draw in these arrows right here. What do you notice about the conclusion of the first statement and the hypothesis of the second statement? They've got to be the same. They've got to be the same. If they're not the same, then the law of syllogism won't work.
It's not silly enough. It's silly.
Transitive property from algebra. Does anybody remember what transitive property said in algebra? So I'll tell you. If A equals B and B equals C, then what conclusion can you draw? A equals C. Alright? That's sort of what the law of syllogism is. Sort of like that. So looking at this example here, we're going to draw a valid conclusion from it. This part's called the what again? Hypothesis. If you get a job, that's the hypothesis. What's this part called? Conclusion. Good. Notice that's one whole statement, and I'm telling you that that whole statement is true. They're giving it to you that that's a true statement. Then the second statement. This is called the what again? Hypothesis. This is the conclusion. So if you get a job, then you will earn money. If you earn money, then you will buy a car. What do you notice about this part, the conclusion of the first statement, and the hypothesis of the second? It's the same thing. So all you're going to do with using the law of syllogism, if these 2 are the same, is you take this part and this part and put them together, and that makes a new statement that you know must be true. So what's my new statement going to be? If you get a job,
And you will buy a car.
why am I putting quit working? And you will buy a car.
Or you don't get a job, take it later.
We know that that is a valid conclusion. But it has to be that way. It has to be where this and this are the exact same. Not, I shouldn't say exact same. They're basically the same thing. Is this on there somewhere?
Yeah.
I gotta look it up in the book, 'cause I'm not sure. I think they added some stuff to it, and we'll just make up something. Sleep scientists have found that the quality and amount of sleep greatly impacts learning and memory. Lack of sleep causes students to have trouble focusing and receiving new information. Sleep deprivation also makes it difficult to retrieve previously learned information. I think there was part of this I forgot to add on to this. We'll just make up something here. So this is telling you, if,
You don't sleep, you can't remember.
so if no sleep,
You don't remember.
then no remember.
Remember.
We'll go with that. Yeah, I spelled it wrong, but just live with it.
Remember.
because I didn't want to put remember. As a matter of fact, I'm going to erase it. We'll put learn. That was easier to spell than to remember. So, if you don't get any sleep, then you don't learn anything. My son, when he's like in his 4th year of college right now, but when he was his first couple years in college, he was taking like Calc 1, Calc 2, and so when he would have a test, he would call me the night before, and we would go over stuff together, just to try to make sure that he understood it. And I would tell him all the time, because we would spend 3-4 hours on the phone, all right, going over problems that might be on the test or things that related to the test. It would get to be 10, 11 o'clock, and I'd tell him, that's enough. Because what scientists have figured out, by that time, he's tired.
He wants to go to bed.
Is he learning anything else?
No.
He's not going to remember this stuff anyway. And what's that also, it's like a double whammy, because if he's staying up still studying, he's not getting sleep, what's that going to do to him on the test? It's going to make his test grade go down, because he's not going to be able to focus when he's doing the test. And that's what I tell him, hey, but Dad, you're not helping yourself from here on out. Now the help's going to come, get a good night's rest. And then you're going to be ready to take your test in the morning, even though you don't think so. So for the law of syllogism, it says, if no sleep, then you don't learn. If you don't learn, what's that tell you about the test?
And you fail. Oh, you don't
Then
get that grade.
poor test. Notice here, what do you notice about this part and this part? Same. So again, what I would always tell him, what should he do?
Get
Go to sleep. So this is telling us, if you get no sleep, what do we know is going to happen on the test? Then poor test. That's the law of syllogism. We can take this, and just put them together as a new statement, and it's got to be a true statement. If the conclusion of the first statement and the hypothesis of the second statement are the same. If you like musicals, then you enjoy theater productions. If you are an actor, then you enjoy theater productions. What conclusion can we draw here? First thing, what's this? This is the what? Hypothesis, good. This is the conclusion of that first statement. This is the hypothesis of the second one. Conclusion of the second one. Can we use the law of syllogism on this?
No.
Why not? This and this, not the same. Not same. So what am I going to write down here for my conclusion? And I'm just going to write no valid conclusion. You can't draw a valid conclusion from this because it's not in the right order. And notice, if we would have put these two together, what would it say? Say the same thing as the first sentence said. That doesn't do us any good. We already knew that. Get your books out. Open up to page 175. 175. Abby, did you have any trouble passing that stuff out for me yesterday? Or day before yesterday, sorry.
Yeah, that's fine. brother's like, why'd you get all this that candy?
Thought it'd be nice since you were helping me out. Huh? Tell them if they were nicer, then maybe they would get some.
This Brandon said that too.
Yeah. I forgot that I had Brandon in my third block, because I probably would ask him to do it, because he was already in there. Huh?
You would have forgot. They would have been at the bottom of his backpack.
Probably a good thing. Page 175, on page 175, we're going to do as many of these as we can in about the next 20 minutes. My first block class, we did like a couple from the first section, then we skipped. I don't care if they're out of order on your paper, whatever. That makes no difference to me. So, we're not going to do the even ones. Not going to listen to Dylan because he thinks he's cute. We should take a vote. Sorry, that's my fault. Sorry, Dylan. I shouldn't have said that. I'm being good. Maybe they'll fire me. That'd break my heart. So I don't care where we start at. We start at number 1. We'll do a couple of those maybe, then jump to something else. Number 1. At Fumio's school, if a student is late 5 times, then the student will receive a detention. Fumio has been late to school 5 times, therefore he will receive a detention. I guess I should have read the directions. Inductive or deductive reasoning? Deductive. So number 1, write down deductive. That's all you write. Number 1, deductive.
Number 2.
Are we doing number 2 or are we jumping to something else?
Number 2.
Number 2?
You gotta go in order. Yeah.
See, I think we ought to do some different ones because these are pretty easy.
Yeah.
But,
Alright, then start at the bottom.
but if you want to go in order, that's fine. A dental assistant notices that a patient has never been on time for an appointment. She concludes that the patient will be late for her next appointment. Inductive or deductive?
Inductive.
Inductive. Using patterns. Are we going straight down still, or are we finally deciding to go somewhere else?
We do number 4.
Number 4? Number 4. If Emilio decides to go to a concert tonight, then he will miss football practice. Tonight, Emilio went to the concert. Emilio missed football practice. What kind of reasoning are we using there? Deductive? Wasn't a pattern, it was just facts that we used. Where are we going to now? 11? Problem 11. Problem 11. Grant, that was a good thing because if you'd done what they had said, I was getting ready to stop and go sit down and let you guys do it all on your own. 11. The directions say determine whether each conclusion is valid based on the given information. If valid, write valid or invalid, explain your reasoning. So I'm going to write this out just real quick here. If 75% of the tickets are sold, I'm not writing out the whole sentences, then what do we know about the prom?
It's going to be at the country club.
Prom at the country club. This part's the what? Hypothesis. This part is the conclusion. Then it says 75% of the tickets are sold. That was the hypothesis here, right? Which law are we using? When you have a whole statement, and then you have a half a statement, which law are you using? Look back at your notes real quick. Detachment, very good. So what can we say? What's our conclusion that we can draw, or actually they draw it for us. What conclusion did they draw? Prom is held at the country club. Is that valid or invalid? Valid, and they won the reason, and the reason is because of which law? We just said it. Law of detachment. Valid because of law of detachment. Number 9. Does everybody have that much so I can erase my board? Number 9, if you leave your lights on your car while your car is off, then your battery will die. Most cars aren't this way. If you have a newer car, my car is this way because it's an older car. But so if leave lights on, then battery die. Again, this is your hypothesis. This is your conclusion. What do they say next? Your battery is dead. Battery dead. And then they say you left your lights on. Left lights on. Is this statement valid or invalid?
Invalid. It could have been for another reason.
All right, it could have been some other reason. And again, look at it. Battery dead is the conclusion there, not the hypothesis. So this won't work for law of detachment. So this is an invalid conclusion. And it could have been some other reason that your battery went dead. Maybe it's just old and worn out. Next one. 18. Problem 18 says, draw a valid conclusion from the given statements if possible. Then state whether the conclusion was drawn using the law of detachment or the law of syllogism. If no valid conclusion can be drawn, write no valid conclusion. 18 says, if, and I'm going to write this real choppy here, if a square, then, sorry, I'm writing in cursive. If a square, then all sides congruent. Then it says A, B, C, D is a square. So this is the hypothesis. This is the conclusion. Where did this come from? It's the what in the original sentence? Hypothesis. So can we draw a conclusion from this if these two are the same? Yeah, what can we say? Then all sides A, B, C, D are congruent. Sorry, that's ugly. Which law did we use? Law of detachment. Law of detachment. Next question. 19. Does everybody have that one? Because I probably don't have room to write 19.
Yeah, go ahead.
All right. Number 19. No, no, don't do that. Number 19. If two angles, no, when you walk in next time, there's probably going to be a definitions test. If two angles complementary, then what do you know about them? Add to 90 degrees. That's your conclusion. Sorry about underlining the then. That's our hypothesis. Let's see, it says angle 1 and angle 2 are complementary. What conclusion can we draw?
They add up.
So angle 1, they add up to what? Angle 1 plus angle, ignore all that. Angle 2 has to equal what? 90 degrees. That's the conclusion we can draw. Is that a valid conclusion? Yeah, because again, the hypothesis here was this statement here. So those two are the same, so then we can say that the conclusion all by itself has to be true. What law did we use? Law of detachment again. I guess that means they're all going to be law of detachment, right? Probably not. Next question. See if they were all as smart as you, Jameson. No, just to leave some space for the ones that we skipped over. That would 30. 30? Does everybody have that one? Yes? Problem 30. As Matei, I don't know how to pronounce that person's name, but that's what we'll go with. As Matei's mother left for work, she quickly gave Matei some instructions. If you need me, call my cell phone. If I do not answer, then it means I'm in a meeting. The meeting will not last more than 30 minutes, and I will call you back when the meeting is over. Later that day, Matei tried to call her mother's cell phone, but her mother was in a meeting and could not answer the phone. Matei concludes that she will have to wait no more than 30 minutes before she gets a call back from her mother. What law of logic did Matei use to draw this conclusion? They want which law? So it's either going to be detachment or syllogism, right? So let's go back to what Matei's mother said. She said what?
Call her.
So if need me,
Yeah.
then call the cell phone, right? I'm not going to write all this out. What else did she say?
If I don't answer a minute.
If no answer, then meeting. What else did she say?
I'll call you back when I need you.
The meeting will not last more than 30 minutes and I will call you back. So if I'm in a meeting, then what's Matei know?
Expects the call within 30 minutes.
Back 30 minutes. So which law did Matei use? Law of, I thought I heard it.
Syllogism.
Law of syllogism. Matei figured, all right, mom didn't answer. That means she's in a meeting. If she's in a meeting, that means she's going to call me back within 30 minutes. So Matei figured, put these two together. I didn't get an answer. Then I know mom's going to call me back within 30 minutes. Law of syllogism. Next question. 24. Determine whether each conclusion is valid based on the given information. Write valid or invalid. Explain your reasoning using a Venn diagram. I don't care if you really use a Venn diagram. We'll try it here and see what happens. But if the temperature drops below 32 degrees, it may snow. So if, how am I going to write this sentence out? If what?
If the temperature is below 30.
So if below 32 degrees, then what?
It might snow.
Then maybe snow. What's this part called? Hypothesis. What's this part called? Again, if we're just writing this out, notice I don't write anything out completely. I'm very, very terrible at writing, and I'm very, very lazy as far as writing goes. And that goes for reading also. I'm a horrible, horrible reader, so when you hear me read this stuff, this is probably when I read that paragraph right there, that was probably the most I've read in about a year. All right? Because I just don't read stuff. My wife tells me, here, read this. Here, read what the school sent us, or here, read what the doctor told you to do, or here, and I say, okay, and I never do it. The temperature did not drop below 32 degrees on Monday. So Monday, temp, not 32 degrees or below. And the conclusion that they drew, it did not snow on Monday. No snow Monday. Using what we have here, is that a valid conclusion? What's this say again? If temperature is below 32 degrees, then it may snow. Does it tell us anything about the temperature if it's not below 32 degrees? Has it ever snowed before when it was 35 degrees? Yeah. Because what's it matter? Does it matter what the ground temperature is? No, it matters what the temperature is up here. All right? So is this a valid conclusion? Not valid or invalid. All right, do me a favor and grab a paper towel. I'll come around and spray your desk.